Hello and welcome to Mr. Tompkins EdTech. With 2 papers down and 1 to go, many of you have been asking about my predictions for topics likely to come up in paper 3. So I thought I'd make this quick series of videos compiled from questions covered in my practice papers and past paper walkthroughs. In each video I've taken one topic I think is a dead cert to come up on paper 3 and created a compilation of all the questions I recorded on just that one topic. Question 17 tells us that Joe asked 230 students how long it takes them to travel to school, and the results are shown in this grouped frequency table. This is Joe's attempt to draw a histogram to show his data. Well, Joe, I think you have not done that right, have you? What does the question ask us? It asks us to give 2 criticisms for his histogram. Well, so there's 2 very clear things wrong with this. Firstly is this bit here, the frequency. Now on a histogram it is the area of the bar that's proportional to the frequency and not the height. So this should be frequency density, not frequency. So Joe should have worked out what all the frequency densities were and then put the bars at that height when he was drawing his histogram. The other thing that Joe's done wrong is his scale on the bottom here. So from here to here is 5 units, here from here is 5 units, but here from here is 10 units. This is 10 and this is 30. So he's using a non-uniform scale along the bottom here. So he's drawn all his bars the same width, but they represent class intervals that are very different. This has got an interval of 5, this has got an interval of 5, this has got an interval of 10, 10 and 30. So these should be the width of those bars, not just a uniform width like it's got here. So let's write that down. My 2 criticisms are Joe should have calculated frequency, density, and used this for his y-axis scale. And our second criticism is Joe has drawn all the bars with the same width and not used the class interval. Question 24. The cumulative frequency diagram shows the times taken by runners to complete a half marathon. So we've got the cumulative frequency curve, and underneath it asks us to draw a histogram to represent the data and use this table to help us. So I think we need to go through and read off the values first. Then we can populate the cumulative frequency table, and then we can fill out the table we then need for the histogram. Okay, so coming back to the diagram. So time under 100 is going to be this point here. So that's 8. Time under 120 is this point here, which I read to be 56. Time under 160 is up here, that's 100. Time under 200 up there, that's 110. Time under 300, that's the last dot on the top, and that's at 120. Okay, so then we can then work out the frequencies from our cumulative frequency. So between 80 and 100 must be all of those 8, so that goes in there. Between 100 and 120, That's going to be the difference between these two numbers. So 56 subtract 8 is 48. So between 120 and 160 is going to be the difference between 156, which is 44. Between 160 and 200 is going to be the difference between 100 and 110, which is 10. And then finally between 200 and 300 is going to be the difference between those last two numbers, which is also 10. Okay, might want to just double check that those numbers add up to 120, 10, 20, 64, 104, 112, 120. Yes, they do. Okay, so the class width is the difference between these two numbers. So 100 take away 80 is 20. 120 take away 100 is 20. 120 to 160 is 40. 160 to 200 is 40, and 200 to 300 is 100. And frequency density I get by, for it taking frequency density is equal to frequency divided by class width. So basically I have to divide my first column by my second one, and that would be my frequency density. So 8 divided by 20 is 0.4. 48 divided by 20, 2.4. 44 divided by 40, 1.1. 10 divided by 40 is 0.25 and 0.25. Okay, so now I've got all the information I need to draw my chart. So my first bar is going to be from 80 to 100, and it's going to have a height of 0.4. So I've not been given a scale for frequency density up the side here. So the first thing to do really is then decide what the increments are going to be up this scale. So I've got to go up to 2.4. That's my largest value. So that's going to have to be at the top of my scale. Counting up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares. So, and I want to go up to 2.4. So if I go 2 squares, so 1 square is, so if I take one little square, oops, if I take one little square is 0.2, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4. That seems to fit in nicely. Okay, so my first bar was frequency density of 0.4 and going from 80 to 100. Okay, now the second bar goes from 100 to 120 and has a height of 2.4. Okay, now the next bar goes from 120 to 160 with a height of 1.1. So notice that one is a bit wider than the other two because it represents a wider class width. The next one is running from 160 to 200, has a height of 0.25. And then finally, well, I've just noticed this one's wrong actually. That should be 10 divided by 100 is 0.1, isn't it? So correcting that, then 200 to 300 at a height of 0.1. So that completes my histogram. Question 22. The histogram shows information about the time some students revise for a test. The first bar represents students who revise for less than 10 minutes. Now, I hope going into your GCSEs, you're going to be revising for substantially longer than 10 minutes. Estimate the number of students who revised for less than 45 minutes. Okay, so less than 45 minutes is going to be all of the first bar, all of the second bar, all of the third bar, and some of the fourth bar. If I get my ruler out, maybe draw a line to show that. It's going to be that part. So it's going to be those 4 bars added together. So we've got the frequency density on the left and the time underneath, so it should be just a matter of working out the area of those 4 rectangles and adding them up. So the number of students is going to be, well, the first rectangle has a base of 10 and a height of 0.8. 10 times 0.8 is 8. Our second rectangle has a baseline going from 10 to 30, which is a width of 20, and it's got a height of 1.6. 20 times 1.6 is 1632. Our third bar goes from 30 to 40 and has a height of 2.2. So again, it's got a width of 10 and a height of 2.2. So that adds up to 22. And then our final bar, we're estimating the width is 5, and we're estimating the height to be 2. So it's going to be 5 times 2, which is 10. So adding all those up, 8 plus 32 is 40, plus 22 is 62, plus 10 is 72. So 72 students. Question 22a. Amy drew this histogram to show the times taken to complete a task. You can see we've got frequency density down the side, and we've got time along the bottom. But what's interesting, I think, is that she's used a broken scale here, which is not really recommended for frequency density. Basically, you're taking a big chunk of the bottom half of the graph out, and it's going to make all the heights of those bars unrepresentative, really. So using a broken scale on a frequency density on a histogram like that is not really appropriate. You know, you can use a broken scale if there's no data along the time. We could have broken a scale and started around about 5 on the time axis without too much damage, but not on frequency density. That's not going to work. So using a broken scale for frequency density, gives a misleading picture of frequency. Okay, second part. Here is another histogram showing the times taken to complete another task. Okay, this time we haven't got a broken scale. Estimate the percentage of people who took less than 30 seconds. So less than 30 seconds, let's just get the ruler out. So less than 30 seconds is going to be everybody to the left of this line, isn't it? So if I can work out the area of those 3 bars and add them up, I should be able to work out the frequency. So this first bar has got a height of 40, frequency density of 40, and it's got a width of 10, so that represents 400 people. The middle bar has got a height of 25 and a width of 10, so that represents 250 people. And this part of this bar here has got a height of 20 and a width of 5, representing 100 people. So my estimated percentage of people who took less than 30 seconds. Well, the number of people is going to be those 3 bars added together. So 400 plus 250 plus 100, which comes to 650, 750. So then that is a percentage. So percentage is going to be 750 out of how many people took the test. Does it tell us? No, that's annoying. So now we need to work out what the rest of the bars are, so we can work out what it is as a percentage. So that's the number of people less than 30. So now we need to work out what the total is. Well, the total is going to be the other bars then. So if I then add up the other ones, okay, so this one has still got a height of 20 and it's got a width of 15. So what's that? That's 300. And then this one has got a height of 10 and a width of 5. So that's 50. So then the total is going to be my 750 plus 300 plus 50. So it adds up to 1,100. So then my percentage is going to be my 750 divided by the 110 times 100%, which is 68.2%. Question 24. 48 students completed some homework. This histogram shows the information about the times taken. Okay, so we've got frequency density along the side, we've got time in minutes down the bottom. Remember with histograms, it's the area of the bars that are proportional to the frequency and not the height. Okay, so we need to work out the estimate of the interquartile range you must show your work in. Oh, that's an interesting question. The interquartile range. So if you remember, the interquartile range is the distance between the upper quartile and the lower quartile. So what we need to do is we need to work out how much time, well, let me just draw this. Imagine all your data points in a line like this, coming from the lowest value to the highest value. What we need to do is we need to find the person who's at Q1, which is 1/4 of the way through the data, and we need to find the person who's at Q3, which is 3/4 of the way through the data, and then we need to work out the distance between them. That's going to be the interquartile range. Okay, so let's have a think about this. We've got 48 students. So if I've got 48 students, then Q1 is going to be well, what we do is we take 48, we add 1 to it, and we divide by 4 to find where the lower quartile is. So 49 over 4, I'm going to say that's roughly 48 over 4 and just do it like that way. So 48 over 4 would be roughly the 12th person through the data set. And Q3 we get by taking the number of elements in the set, adding 1 and times it by 3/4. So I'm going to say that's roughly, again because it's going to give me a bit of a weird number, I'm going to say that's roughly the 36th person through the data set. Okay, so where is person number 12 and where is person number 36 in this data set? Well, now I said earlier that it was the area of each bar that is proportional to the frequency. So if I take this kind of thin toolbar between 0 and 5 here, the area of this bar is going to be the class width 0 to 5, which is 5, times by the frequency density, which in this case is 1.6. Now 5 times 1.6 gives me 8. So that bar represents 8 people. Okay, so person number 1, 2, 3, 4, 5, 6, 7, 8 are in that bar. Okay, now the next bar stretches from 5 to 15, so it has a class width of 10, and it's got a frequency density of 0.8. That's the height of the bar. So if I times those together, again, that gives me 8. So the next 8 people are in this set. So the first 8, 1 to 8, are in the first bar, and the next 8, which is going to be person number 9 up to person number 16, are going to be in that group there. Okay, so remember we were looking for the 12th person. So our 12th person is going to be somewhere in between that bar. We're going to have to kind of estimate how far along in a minute. Let's just finish doing the areas first. This third bar has a class width of 10 and a height of 1.2. And that tells me that this represents 12 people. And then finally, the last bar has got a class width of 20 and a height of 1. So that represents 20 people. Let's double check that adds up to 48, 8, 16, 28, 48, yeah. Right, so like I say, we were looking for the 12th person and the 36th person. So if I've got my first 8 people in here and my next 8 people in here, then it's going to be halfway up that bar, isn't it? So the first 4 on the left, the next 4 on the right. So I'm going to estimate that my median, my lower quartile is going to be halfway along that bar at my 12th person. So that's going to be my Q1. Okay, and then my Q3 is my 36th person. So 8, 16, 26, 28. It's going to be in this big fat bar at the end here. So if that was 28th person and this one then is the 48th person, and I'm looking for the 36th person, how far along that bar is it proportionately? Okay, well the distance between 28 and 36 is a distance of 8, and the distance between 36 and 48 is a distance of 12. Okay, does that help me? So that adds up to 20. So it's going to be 8/20ths along that bar, which cancels down to 4/5. No, 4/10. 4/10 of the way along that bar, then, isn't it? Okay, that I can work with. So I'm going to have to estimate what's 4/10 of the way along from here to here. So 5/10, that's pretty obvious. It's there, isn't it? So where's 4/10? If I was going to divide these 20 jumps into 4, it's going to be 8 along, isn't it? So it's going to be 8 little squares. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be here. So my Q3 is there. So we're saying that Q1 is equal to 10 and Q3 is 33. So the interquartile range is just given by Q3 subtract Q1, which is, we now know, is 33 subtract 10, and 33 subtract 10 is 23 minutes. Check out my other predictive topics by clicking on the card appearing here. Also, you can check out my practice paper walkthroughs by clicking on the card here, or you can even go through actual past papers by clicking on the card over there. Good luck in your exams, and I'll see you next time.